webinar on sustainability in construction. My name is Ali Golavci, and I'm the Associate Director of the CIC. This session is organized jointly by the Construction Innovation Center, or CIC, at the University of Alberta, the Offsite Construction Research Center at the University of New Brunswick, and the Center for Innovation, Construction, and Infrastructure Engineering and Management at Concordia University. We have some great presenters lined up for this webinar, so I'll go through some quick items and then we'll get started with the presentations. This session is being recorded, and the link to the video recording will be shared with everyone who has registered through a follow-up email. For this webinar, we have 3 presentations, and we will have a kind of panel discussion and a Q&A after the presentations. Throughout the presentations, please type your questions in the Q&A area, and we will refer to them after all the presentations are done. We're now going to start with the first presentations by Anna Rubak. Anna is the Principal Director of Research and Innovation at WSP Canada and also an adjunct professor at the University of New Brunswick. Anna, great to have you. Please go ahead.
Thank you. I will just share my screen now. All right. As Ali said, I'm Director of Research and Innovation at WSP Canada. And that means that across our 12,000 engineers, scientists, and planners, you can probably imagine we're always trying to evolve what we're doing and evolve our practices. So my role is about helping people find ways of getting their ideas all the way through to commercialization. My background is in asset management, and I spent many years consulting on the whole of life of assets and how much to invest in them. And at a certain point, traditionally asset management looks at how long an asset might last, what might change in terms of how many people are using that asset over time. But traditional asset management, and I'll say new asset management, there's quite a change now. We're looking now at trends in climate and how that will affect the future of our assets and what we might have to do differently. Trends in society and not just population increases. So there's a really big shift in what's happening. And a few years ago when I joined WSP, the company was just launching its Future Ready program. And now it's the only lens I can put on the world is looking at trends. The premise is so simple and it's so compelling. You look at these projections in the next 10, 20, 30 years, and then you design, plan, and advise our clients and communities in new ways that help us prepare for the future. But the implementation isn't that simple. And I'll share some of our experience here at WSP, and I'll also share some of the research that we've done into why individuals and companies, organizations just don't adopt new technologies and new ways of doing things when it seems so obvious. The main thing that I hope to take away, that I hope that you take away from this, is that change is possible with new structures and new collaborations. And so what I'll cover today is more about how Future Ready works, the imperative to apply it in our work. And then I'll show how some trends are increasing the volume and unit cost of construction. So in at least 3 different dimensions, there's massive changes coming that will increase the costs. There's a lot of dimensions that I could explore more with you, but I'll dive very specifically into how we might be able to reduce some of those unit costs using technology. I will also touch a little bit on green infrastructure and behavioral change, but that's where I'll mainly focus on the technology and the unit costs. And then because I've learned that some of the best ideas aren't automatically adopted by most of the population, I'll show why that is, those barriers, and some ways we can work around human nature, or maybe with human nature, if you prefer to think of it that way. The Future Ready program, I've really already said it. It's so simple and compelling that there's not much need to say more. It's really about guiding engineers, planners, and scientists to offer more resilient solutions, to think of more resilient solutions by considering the future in the work that they do. And then you incorporate those future considerations into your design, advice, and construction. It is really simple. So those are the main pillars: seeing the future more clearly, developing complete solutions for the long term, and challenging the status quo. Now, you're saying that's a bit high level. I will show you a little bit more of the detail into exactly how it can work. This Future Ready framework, this is essentially it in a nutshell. These 4 different trend categories that we look at in climate, society, resources, and technology. And I'll take some examples. These trends that I'm showing you here are mostly from the city of Fredericton. If the data were at a more aggregate level, that might be provincial, or even in some cases, national level data. But here's what you do. For the climate, for example, our maximum 5-day precipitation will increase by 10% by 2050. So what does that mean for our built environment? Well, 10% doesn't sound like a lot, but it might mean a lot more area is covered by flooding than what we have right now. So that might mean you need to think about zoning setbacks. You might not want to build in places you've been building in the past. With weather will become less predictable, which can make it a struggle when you're planning construction. Something might come up and you just might not be prepared for it. The number of hot days will increase by 250% here in Fredericton. So that is massive. Now that could shift the tipping point of the kinds of decisions you make, the kinds of economic decisions about insulation versus positioning of building, even location of a building. And I'll just touch a little bit on society, and then the rest of them I'll leave you to glance at yourself, but they're fairly self-explanatory. So in society, people with disabilities will increase by 24%. Now, in New Brunswick, we already have up to 30% of the population living with a disability, so it is a huge amount. So what does that mean for the way we'll have to design our buildings, our built environment differently? We'll really have to think hard if we want everybody included in the community and also participating fully in society. Newcomers will increase, which means what? Well, it could mean we need to make it easier for people to find their way around. And the number of low-income families will also increase. And how do we give them access to the kind of infrastructure and housing that they need to keep them healthy and contributing to society? And the other 2 trend categories you see are resources. That's all about, there's a big piece there on circular economy, and you might see some of the other speakers talk on that. Net zero, really hot topics in construction. And then the technology side. Technology is much harder to predict. Any predictions we looked at for technology were only, 5 years out at the most. And typically, when I Google technology predictions, it's for the year ahead, and that's it. So it's a big challenge. And as you will have all seen in the past year with the rise in machine learning and artificial intelligence more generally, it has really picked up. So here's a major sustainability challenge in the construction industry. I try to wrap it up into what I call the bitter pill. So there's 3 elements to this. There will be more construction, and the cost of each piece of construction will increase because asset lives will last less long than they have in the past. Heat will make pavement melt. Increasing storms will batter buildings. Increasing storms and flooding mean that we actually have to replace our culverts with bigger culverts and our stormwater systems with something different. We'll have an increased demand for infrastructure. So I showed you the increasing heat element. With increasing heat, it means we'll need to perhaps insulate more. Maybe the buildings needs to be insulated. Maybe electric cables need to be insulated in ways they haven't. We'll probably need to provide cover for people because when they're outdoors, well, now they want to spend time outdoors, but it's just too hot a lot of the time. So what do we do about that? And then on the water side, with increased heat, we'll simply have less water. So perhaps we need to build bigger reservoirs, for example. And then the cost of inputs will also increase. The cost of labor will increase. As you can imagine, being outside when it's hot, maybe it means you need more PPE. Maybe it means you need to take longer breaks. So the construction season, the construction duration might be longer. Here's the bitter pill I talked about in the 3 dimensions. Just for a bit of fun, You can see that axis A is the replacement frequency, so the asset life just lasting less long. So that cost, you have to replace it more often. That just builds up costs over the same amount of time. The quantity of asset, again, imagine increased heat and increased cover, we need more assets. And then the third dimension there, C, the unit cost. What is the cost of those inputs and how they will change over time? Now I'm going to dive into those unit costs for a couple of examples of how climate in particular will be changing. What you have across the top is labor. These are different elements of cost of construction, materials and equipment. The next one across is insurance. And then the next one across is time. And so what I'll do for each of these elements of unit costs is I'll show you how they'll be affected by increasing heat, flooding, and increasing storms. So the first one you see is for labor and heat. And I've already mentioned those. People will need increased cover and increased cooling to keep them protected. Then what will heat do to equipment and materials? Well, you'll probably have more frequent breakdowns, or you need more downtime for equipment. You'll also need more resistant materials, which may be more expensive. In terms of insurance, I can't say there's a lot direct relation to heat, not one that I thought of anyway. But then in terms of time, there'll be much more downtime for your equipment and for your people. All of those are just a few examples of how the costs of construction will increase based on increasing heat. Now, based on increasing flooding, employees will need to take leave. They'll need to take leave because their properties will become flooded. I've seen some research that shows that people affected by flood take about 10% more leave, which can't be surprising at all. You need to deal with these kinds of things. In terms of materials and equipment, of course, flooding will cause damage on your site, and they'll also cause disruptions to supply chains. Now, in terms of insurance, flood insurance will start costing more because we will have more flooding. And then in terms of time, of course, there'll be disruption to schedules because of flooding. And that could be because there was a supply chain disruption, or it could simply be because you had to halt your construction because of flooding or extreme weather. Now, finally, extreme weather, what will that do for your employees? Well, an increased risk of injury to them. In terms of equipment and materials, increased storm will increase damages on your site, and increase supply chain disruption. In terms of insurance, of course, the cost of insurance for storms will increase as well. And finally, in terms of time, of course, your schedule disruption will increase because of increased storms. Now, I did tell you that I would be diving specifically into the role of technology and how it could mitigate against these, against these increasing cost elements. Technology is not the only way. There are some fantastic green solutions and behavioral solutions that apply to not so much on the construction site, but more so deciding what will be built in the first place. But now diving into the role of technology specifically. It is changing fast, as I mentioned before. There are some huge potential cost savings there. So you can see some different areas in terms of procurement, sharing of information reduces uncertainty, so that when people are bidding for certain projects, the price can be reduced because there's less uncertainty inherent in that. It's also been shown, BIM, for example, has also been shown to reduce disputes because everything was already shown on a really clear model to begin with. So that's another cost savings. On the design side, because there's more accuracy introduced through building information modeling, that actually reduces the rework. And there have been examples shown where rework was reduced by about 20%. Then in terms of the review aspect of design, that data sharing also reduces the time and cost to do reviews. And then in construction, There are several different technologies. 3D printing, for example, can cut up to 2/3 of the cost of construction. Now, not in every instance. This is specific to complex shapes. So if you have a simple building, 3D printing is probably not going to save you anything. But for more complex shape, it can save a lot. Real-time location systems, just knowing where your vehicles are, where your employees are, where your materials are at any time, has been shown to reduce fuel consumption, labor, supply chain costs by 10 to 20, 30%. Imagine knowing that, oh, we have one more pipe there, we need to order the next round in at a glance. Wearables on site have been shown to reduce lost time injury because employers are able to see where there is fatigue starting to set in. And then BIM has shown to reduce the actual project time by about 20%. And the last piece is on training. And this one is a little bit harder to measure, but training technology has been used to train new staff following the movements of more experienced staff and the way they move around on site, the way they lift things. Those learnings from machine learning, from AI, have been transferred to new staff. And then, of course, augmented reality and virtual reality provide a safe, immersive learning environment. And so even with just technology, you can see a few ways that we can start to mitigate the costs that are upon us. Now, keep in mind that there are those other two dimensions of increased construction costs, the demand for the assets, for the infrastructure, and then the life of the assets. So you can imagine how green infrastructure and behavioral nudges, as well as technology, bring a huge potential to reduce demand and increase asset life. We did some research into green technology and behavioral nudges to understand why people do and do not adopt these new technologies. And we narrowed it down to 5 top barriers. And here they are. The first one is simple. It's the fear of the unknown. If you've never dealt with something before, then you don't even know how to make a decision about it, which is really closely tied to the next one, which is a lack of experience. Of course, if you don't have experience with something, you don't know how to make a decision about it. You don't even know where to get started or how to get started. Now, another interesting barrier is around the way we make decisions as organizations. So a challenge here is that decision-making structures don't necessarily enable us to do things in new ways, to adopt new technologies. Maybe technology is in the IT department, and maybe sustainability is in the sustainability department. So how do they come together to make decisions to start bringing in smart technology that improves the sustainability of a building, for example? A fourth barrier is simply strong, resistant stakeholders. Sometimes it's groups that have a stake in a certain material or a certain way of doing things. It could be laborers who are afraid that their jobs could be taken away. And finally, the one we probably hear the most often about is the upfront cost. This is just to show that while costs play a huge role in being a barrier, they are certainly not the only challenge. So knowing what these barriers are helps us understand what we're up against, and we can then start to plan. Now, reframing these a little bit into a model that shows you where these uncertainties and where these perceptions fit in. There was a technology acceptance model developed back in 1989, and it still applies today. And it really centers around how easy people think it is, their perception of how easy it is to use a new technology or adopt a new way of doing things. This applies well beyond technology. And then how useful they think that this new technology or thing is. And between that perceived ease of use and its usefulness is they form their attitude toward this technology. And then, of course, do they intend to do something differently as a result? And so we typically think about training and evidence base as being the biggest barriers. You know, we haven't proven it. We don't have a solid business case. We can't prove it with numbers. And those are really important. as you can see here, the evidence base would help people understand how useful this new technology would be, and then information and training also helps them feel that it's an easier thing to use. And awareness works. In a really interesting study that was done around green infrastructure in particular, this graph shows you the change in uptake, in an intention to uptake green infrastructure when new information is introduced or when a little bit of training is introduced. So what you have here on the left-hand side is what we call the control group. So regular us choosing gray infrastructure. 65% of people were choosing it. And then 35%, of course, were choosing green infrastructure, which is already quite good. Then after they receive more information about green infrastructure, not even anything earth-shattering, just some of the basics about what it costs and how it works, suddenly this shifted so that 90% of people were willing to try to implement green infrastructure, which is a massive jump. Now, there are other important factors too. Yes, education awareness works, but I'm going to say that these are some of our major overlooked factors. Are our family, friends, and colleagues adopting it? Because if so, suddenly we feel much more comfortable with our ability to use it and lean on people to ask them questions about it. And secondly, and related, whenever people act as champions for this, for something new, they help shift. They become that family and colleague and friend that tries something out and shares it with industry. As an example, there was a piece of research done on doctors prescribing new medicine. So it feels pretty risky to them, right? And it turns out they didn't go search for a lot of information to inform themselves more about the drug that way. Instead, they first and foremost relied on their pharmaceutical rep. But the second one, and I think this one is really interesting, they looked around at what their colleagues were doing. And if their colleagues were prescribing it, they were more likely to prescribe it. So it just really shows the power of colleague and other people in industry. The power of the champion just can't be underestimated. Now, how do you use this information to make change? It's really simple what I'm about to show you. We need a policy that sets commitment at the very highest level of the organization. And then assigning roles and responsibilities to carry out certain actions. And then having tools and templates for people to follow steps. It is so simple to say, but a policy does take some stakeholder gathering to get around it. Now, in our Future Ready program in WSP, we right away went to the tools and templates because we thought this will make it so easy for people. They'll get it, they'll be able to pick it up and go. And while it did make it easier, the thing that we were missing early on is having people that were actually accountable for applying Future Ready in our projects and a policy that set that commitment. So these are absolutely critical to making change in industry. And that's really what I wanted to share with you today. And I hope that you now believe that change is possible. I hope that perhaps some of these trends that I shared with you and your impacts are ones that you hadn't seen before, and that there are now new ways of thinking about how you might approach those. Thank you very much.
Perfect. Thank you, Anna. Very exciting presentation. Just a reminder for everyone to put your questions into the Q&A area, and after the presentations, we will get to them. So next we have Terry Matthews and Amin Hamad. Terry is the director of the Town Plus Gown NYC program, an open platform for academic institutions to partner with practitioners on research focused on the built environment, based out of the New York City Department of Design and Construction. Amin is a professor at Concordia University and the associate director of the Center for Innovation in Construction and Infrastructure Engineering and Management. Terry and Amin, the floor is yours.
Okay, so I will share my screen. I will start. Do you see my screen?
Yes, we do.
Okay. So thanks for the introduction. Again, my name is Amin Hamad. I'm professor at Concordia Institute for Information Systems Engineering and Associate Director of CICIEM. And our topic is about potential role of utility doors in improving the sustainability of our cities. So here I'm showing the problems of buried utilities. Most of us are familiar with these scenes. So these utilities are buried in a way that is very difficult to locate and access for inspection and maintenance. That will result in repeated excavation and related costs, and also the social and environmental costs, for example, the traffic congestion and detours. Also, we have the utility interference, which is a huge problem. So we can conclude here that this is not really a sustainable practice. In fact, we have a very nice solution for this problem, I call here multipurpose utility tunnels, or MUT. And we have a definition here. An MUT is an underground utility door containing one or more utility systems that will permit the installation, maintenance, and removal of the systems without making street cuts or excavations. We have a couple of examples. The one on the left is from Prague, which is a pioneering city in this type of projects, and another one on the right from India. In fact, we have also utility tunnels at Concordia. So a couple of weeks ago, I had a chance to visit one of these tunnels. Here you can see the different pipes for HVAC, for gas, and also the electrical cable conduits. We can classify these tunnels according to the depth. So we have flush fitting, where it's not really walkable tunnel, but it's very easy to access. We have shallow tunnels up to 2 meters depth, and we have very deep tunnels like this one, about 80 meters up to 80 meters of the depth. And we have some of these tunnels built in Qatar recently for the soccer games. They built a new city where they have this type of tunnel networks. I have another example here from Singapore. This is a more sophisticated tunnel where we have multiple compartments to separate the pipes, the municipal utilities from telecom and electrical cables. So that will give more secure access to different utilities. And in fact, as I mentioned, this is not really a new invention. So these tunnels have been used the first time in Paris in around 1866, and then another tunnel in London, then other cities in Europe, and then the idea spread to other parts of the world, as you can see here. So in the 19th century, there were only 3 of these tunnels. And then we started seeing more of these tunnels in the Far East, in Japan, for example. And even in North America, we have many utility tunnels, but they are more in institutional facilities, like the one that I showed you at Concordia, in university campuses or military bases or airports and so on, but not really under the roads. We don't have any tunnel, as far as I know, under a public road. Here we can see more and more tunnels up to 2000. And then in the last 10 to 15 years, we see a lot more of these tunnels built in China. In fact, that's because of an initiative by the Chinese government. So they have about 10 pilot cities where the Chinese central government was paying for these tunnels, and they are still building a lot of these tunnels. We can see also some of the projects in the Middle East. Here we can see more details about what to expect in a utility tunnel. In fact, this is an actual design that was designed to be built in Montreal, but it was not realized because of budget limitation. So we can see the sewer and water pipes, the gas pipe, the different types of cables. We can see also the security camera here, sprinkler, drainage structure, ventilation duct. And in some cases, we may have dedicated access for large equipment and workers, as well as the lateral tunnels that will connect to the buildings. So it's not a single tunnel under a single segment of the road. It could be a network of tunnels. We can appreciate the advantages of these tunnels, but I have here 2 slides. The first one talking about advantages for utility companies and municipalities. We have major reduction of maintenance cost, improved inspection and maintenance of utilities, future development and upgrade cost saving because we have extra capacity for the future, and many other benefits. We have also more benefits for the users. So here we are talking about social and environmental benefits. such as major reduction of traffic congestion, improved health, improved safety, major reduction of environmental pollution, and so on. On the other hand, we have some disadvantages, mainly the high initial cost, especially in case we are building these tunnels in developed areas, developed urban areas, so that will require a lot of cost to be assigned to relocating the utilities and so on. We have also compatibility and safety issues, for example, gas leakage. In fact, we have solutions for that. We have a lot of sensors that can help in the early detection of any leakage. We have coordination and governance issues. Who is going to manage and control the access to different assets and so on? We have also security risks like terrorist attacks. And as mentioned in the previous presentation, we have less known construction methods, for example, for this type of projects. And as I mentioned, related to the cost, we have disruption of services during construction, and that's more specific to building these tunnels in established areas. We looked also at the economy of MUTs. So here we have the different phases of the life cycle of a tunnel, the planning and design, the construction phase, the operation phase. We have these two major groups that I mentioned for the costs related to the utility providers and municipalities versus the social and environmental cost. And as we can see here, we have the pink showing the costs related to buried utilities versus the blue bars showing the cost related to the MUT. So we have high initial costs here for the MUT versus very high social and actual cost for the buried utilities in the operation phase of the projects. We did a couple of studies. I'm showing here the study related to the MUT economic assessment and cost sharing. So in this study, we have two phases. Phase one was about the life cycle cost assessment or economy assessment. So here we want to see if the MUT is an economical solution for a specific location. I should mention here that the MUTs are not applicable everywhere because they are costly. So here we are going to compare the life cycle cost of buried utilities versus the life cycle cost of MUT. And based on that, we can decide whether a certain location is a feasible potential target for the MUT. The phase two is about the life cycle cost sharing. So here we try to see how the city or the municipality is going to share the cost with the different service providers, for example, electricity company or gas or telecom and so on. So we have to think about how to share the cost. And also we may want to adjust the cost to improve fairness, considering risk and benefit factors. So here I'm showing an example about how we can distribute the cost between the municipality, the gas company, the electricity company, telecom company, and we can see different on the scenario. In all cases, the city has to bear the majority of the cost. In our study, it was followed by Hydro-Quebec, which is the local power company, and then we have the gas and telecom. And also you can see that we were able to define different scenarios to adjust the cost based on the level of the risk related to each of the utility providers. We had another study about the location selection. As I mentioned, we have to define the most feasible locations. We applied here multi-criteria decision-making for MUT location selection. We have a lot of factors to be considered, but basically we have to look at the high traffic density above ground for the roads. So we have the annual average daily traffic. We have the road class. We have also the population density in that neighborhood. We have the land use. On the other hand, we have to see the utility density. So whenever we have high density above ground and high density below ground, that will be an indicator of a potential location for the utility tunnels. We have other factors here also related to soil type and so on. We collected a lot of data from the city and we applied this data in a case study. So we have a lot of maps, GIS data related to the traffic, road class, population density, land use, also water break rate, electricity network, and so on. We didn't have access to all the data from private companies, but we got enough to do the study. And we have also other data related to public facilities, location of high-rise buildings, and so on. So based on this study, we were able to locate the most feasible locations for the utility tunnels. As expected, we found that most of them are in the downtown area. So we have a score assigned to each location. In fact, this study resulted in a report published by CICIEM, which is an institution for research about public infrastructure systems. And the study was supported by funding from the city of Montreal. We have the report in both French and English. And I was very happy to see that the city, Montreal city, is taking this initiative very seriously. So they considered embedding one of these tunnels in a recent urban development project. In fact, also I should mention that while doing this research, I felt a bit lonely, and the students also felt a little bit frustrated because we thought that we are the only one in North America doing this type of research. And then I was very happy around 5 years ago, Terry contacted me from New York City, and she mentioned that they have similar initiative that I think she will be explaining in her part of the presentation. Thank you.
Okay, let's see if this works. Share screen. Oh, I think, Amin, you have to undo you.
I stopped sharing, I think, no?
Okay, hold on. This is where everything breaks down for me. It's technology. Okay, let's see.
Is it the same one you sent me yesterday? I can share on my...
Yeah, but I should be able to, I'm gonna try not to swear because that's bad. Hold on. Do you see this? Is everybody seeing my presentation?
No.
No, okay.
Okay,
All
let me
right.
share on my side, Terry.
If you do that, that would be great.
Yeah, sure.
Okay. Okay. Let me get back into the Zoom. Oh, there we are.
Okay, let me...
Okay.
You can see the slide?
Not yet. We see you.
Oh, sorry, 1 second. Share screen. Okay.
Well, while you're doing that,
Oh, we'll see what's happening.
is it because I tried to
Yeah,
share?
sorry. Now it works. Now it works.
Okay, that's looking a little bit better. Here we go. Okay, thank you very much. So, hi, I'm Terry Matthews, Director of Town and Gown, New York City, which is a government-centered research program that brings together academics and practitioners, city agency people, on research. We do a lot through experiential learning programs with the various schools in the area, and we also have a funded, it's a master contract for funded research. So today I'm picking up where Amin left off because I was focusing on this potential way of looking at calculating GHG gas savings from implementing utilidors, which by the way hasn't happened yet. Okay, so next slide, please. Okay, so you don't have to read this, but the thing is there are like 10 people who talk about utilidors. You're talking to 2 of them. We're all looking at the same literature. And Professor Hamad's work has been really helpful on our end, but it's financially sustainable. And everybody's been saying it's environmentally sustainable. And Yeah, you can talk about traffic emissions. I mean, calculating all this stuff is really hard when we don't even, it's just hard. And so in this article, I thought, well, you can definitely calculate the savings from not needing to do construction in the future, which is getting to the next slide. Oh, let's see. I'm really not good at this. This is the work that brought Professor Hamad and us together. We had a life cycle cost benefit project. Columbia School of International Public Affairs actually used our data, our construction data, to do phase 1 of his approach, which is the life cycle cost benefit analysis. It was done. It showed positive over negative, which is always good as a preliminary sort of result. And last fall, we began a value engineering study. This was official, New York City, to validate that assessment. And that process is ongoing. Professor Hamad actually participated in that one as well. But now we move over to the next one. So we know it probably makes economic sense. But for this moment, so that was our Utilidor working group. And for this, okay, so what are the environmental benefits? You can look at reductions in traffic detours, but in a city like New York, you're always going to have something. So it's unclear how you model that, although it just seemed simpler and actually related to the work that Professor Hamad did by looking at the reduction in CDW. Because once you put something in, you don't have to dig up the street ever again. And that seemed a lot closer to the financial model that Professor, like it comes from that. So we have an urban resource recovery working group, and let's keep going. So what we're doing here, this is like a nice visual. It's the only nice visual I have, so showing the construction system. This, I'm not going to go into it because I can't remember how I did it in the first place, but it applies transaction cost economics. I did this one day and I thought, well, let's look at the economics of the thing. You have a construction project, it generates CDW. Where does it go? It could go to be reused, or it can go to the landfill. And this looks at all the participants and starts looking at the economic, because everybody talks about green economy. Well, at some point you got to focus on the economy and you got to focus on the businesses that are doing it. So that's the big kind of thing that's going on in the Urban Resource Recovery Working Group. Go to the next one. So in this, we've been at this. We actually started this working group in 2017, focusing on reuse of recycled concrete aggregate. And the more we look into recovery and reuse of construction demolition waste, it becomes very material specific. Like you have to do it for concrete, you have to do it for soil, you have to do it for gypsum, which is a wallboard, because when you break down this stuff, they have properties and stuff like that. So, but last spring, we focused on excavated soil because we learned of a company in Long Island that takes excavated soil, which has a high proportion of sand, because that's the glacial till from the glacier that left on Long Island. And this company takes it and washes it. It's a technology that was developed in Ireland. They bought it, they wash it, they separate it into sand that can be reused into concrete, small stones, large stones, and silt, which is dirt. So we had the students do a calculator for the difference between sending the soil, excavated soil to a landfill versus sending it to a processor to separate it out and reuse. And it kind of comes down to transportation costs, which has an impact on GHG emissions, plus the GHG emissions that you save by not mining new stuff. So we have this very simple, and you can go forward. They made a calculator where you can plug in things and you can, don't ask me to explain this, but this is how you do it. And it is actually really fact specific. It's like, what's the size of the truck? How many loads can you get in a truck in a day going between two places? But the students did it. So there's the transportation cost savings. And then go to the next one. You can do GHG gas emission savings from not doing all this transportation. And so this is the sort of framework for the next slide, which was, hello. See, I told you that was the nicest one. So I looked at this and I went, okay, so we got a calculator. And let's go back to utilidors. Once you put it in, and there's going to be, they're going to be new, that's your baseline, kind of like when you did the financial modeling. In the literature, we multiplied the cost of direct burial by 2 and said, that's your number. But once you put it in, there are costs, environmental costs to all of that, usually probably like the GHG costs of mining the new materials, because you're not using recycled materials for a new utilidor. But once that's in place, it's all the things that you would have been digging up the street for. And let me tell you, it's a lot. You're digging it up, you're putting it back. That's where you can start calculating, and you can use that calculator, that simple. This is not like physics. This is very simple math, but it requires a lot of facts, and you have to get into the fact specific. So I said this was a conceptual model trying to tie together the utilidor, which someday may be implemented, and building the case that you can save a lot of future GHG emissions once you put it in place. So that is my conceptual model. That's where we are today in Town and Gown. It's the last slide. This is going to take a lot of more work to do, but since we haven't implemented utilidors yet, we have time. Just a few words. What I said at the beginning, we're like a facilitator between academics and practitioners. Experiential learning, all of this work, they were done by graduate students in New York schools. Go to the next one. This is my other nice slide. We're also a systemic action research where you do the work and you keep cycling it through to get to a result. And these are our disciplines. And that's pretty much all I have to say. Did I go over, or am I good? Yes. So it's food for thought, okay, among people who are now understand about utilidors.
Great, thank you, Terry and Amin. Okay, for the next presentation, we have Jack Ashton, Sean Allers, and Mary Baczynski from the City of Edmonton. Jack is the General Supervisor, Service Support for Facility Infrastructure Delivery at the Integrated Infrastructure Services. Sean is the General Supervisor for Facility Engineering, and Mary is a Climate Resilience Engineering Training at Planning and Environment Services, all from the City of Edmonton. Jack, Sean, and Mary, thank you for joining us. Please go ahead.
Thank you, Ali. I think you stopped my video, so no one can see me probably. But that's okay. If you can hear me, that's good enough. So thank you for the introduction, and Sean is going to be guiding the presentation today in terms of the slides and such. So good morning, and thank you for the opportunity to present to you regarding sustainable design and construction practices at the City of Edmonton. I'm going to introduce my colleagues, Mary Baczynski and Sean Allers as well, who will be part of the team presenting to you. We're here to talk about the City of Edmonton's sustainability policies, C532 and C627, and how they relate to ongoing work within the City of Edmonton. And time permitting, we'll answer some questions at the end. Next slide, Sean. Thank you. So our agenda today is to discuss the C627 climate resilience policy. Mary will be providing an overview. Sean will be providing a little bit of history and background about how we take the policy and start to implement. Thank you, Ali. Start to implement some of the policy requirements. And then I'm going to actually talk about some of the projects that we've recently completed that were a result of the policy being implemented. And then questions. So next slide, please. And Mary, feel free.
All right, so here's some background on why we have C627. So the Edmonton Declaration was developed in 2018 at the city's IPCC Science and Climate Change Conference and calls on cities to do our part to contain climate change's impacts to 1.5 degrees global warming. Following this declaration, Edmonton City Council declared a climate emergency in 2019, and this led to stronger targets such as achieving an emission neutral corporation by 2040 and a carbon neutral community by 2050. So Climate Resilience Policy C627 includes this targets and its administrative procedures help achieve it. So next, we have the city's corporate emissions since 2015 compared to our target to reach emission neutral by 2040. So the stacked bars here represent our total corporate GHG emissions, and then the light green is the negative emissions, which are primarily from renewable energy certificates called RECs that we purchase to cover emissions from electricity consumption, as well as some sequestration from our urban forest. To get to our 2040 net zero target, we need to decrease our net emissions by about 6% per year. And on the next slide, we have a breakdown of the corporate emissions by sector, not accounting for those RECs for electricity consumption. You can see buildings make up about 50% of our corporate GHG emissions, so they're a large focus of our emission reduction efforts. And the next slide, we have the C627 Climate Resilience Policy, which was approved by Council in April 2021. And it includes 3 main commitments: to reduce our emissions, to adapt to a changing climate, and to lead climate solutions. Leading climate solutions reduces our own emissions, demonstrates leadership to the community, and advances industry practices towards more sustainable construction. And on the next slide, here are the administrative procedures under C627 for buildings the city builds, owns, buys, leases, and funds. So with the target of being carbon neutral by 2040, both our new and existing buildings will have to align to meet this target. And the focus today is on the procedure for the design and construction of city buildings. And the next slide are the design and construction requirements. So the most significant requirement is that new buildings are designed to be emission neutral, which is defined as a building that is highly energy efficient and uses only renewable energy for its operations on an annualized average basis, or produces and supplies on-site renewable energy in an amount sufficient to offset the annual greenhouse gas emissions associated with the energy consumed for its operations. There are additional requirements as well, to consume 20% less energy than the code requirement, to meet a thermal energy demand intensity target based on the space use. That 1% of the capital cost goes towards renewable energy. There are requirements for an embodied carbon assessment and a climate risk assessment, as well as achieving LEED Silver or higher. And now Sean will explain the history and background of C627 and how these targets were developed.
Thank you, Mary. Like was talked about, we sort of had two policies. A lot of the information from the older one, C532, got used for the newer one. So back when we were starting to think about this in C532 time, we're asking ourselves, hey, what metrics should we use to define what these new sustainable buildings should look like? We had an old policy that referenced MECB 1997, for those who remember that. So comparing buildings to a standard was something we felt we could start with, except we would obviously use at that time National Energy Code 2011 as the baseline. But the real goal of the policy was greenhouse gas emission reductions for the new buildings. So we wanted a target that sort of was associated with that. So we were looking for, again, something related to a standard, NACB 2011, and on greenhouse gas emissions. So the other thing, though, a lot of us who've worked in the buildings industry for a long time was we had not seen a real good proper investment in building envelope when we're building new construction. Building envelope is likely the most important component of the building, and this is from a mechanical engineer. Because it has such a high initial cost, a lot of times it wasn't receiving the investment it needed. So that's why we looked at a third metric to add on there. So now that we had the metrics, how far do we go? What's the cost? What's the GHG savings? To find out these answers, we did 3 studies. The first was a retrospective study on 5 city building archetypes: a fire station, a police station, admin building, rec center, and library. This helped give us an idea of our current state or business as usual relative to NACB 2011. As you can see, just designing and constructing things as we were already exceeding 2011 on a lot of different fronts. For the police station shown in the graph there, we were more efficient than NACB 2011 on all fronts, but especially on the heating side. So the other thing this study did was look at pass forward to higher levels of energy efficiency for each of those different archetypes. A piece of software was used by the consultants that looked at different envelope and mechanical system options, and then looked at scenarios that gave us the highest levels of energy efficiency for the lowest capital cost. You can see one of the results for a single scenario from that software sort of displayed on the screen with the inputs on the left and the outputs on the right. So once we had the software set up, we ran hundreds of different scenarios to look for the most cost optimized bundle. Most of the buildings like police, fire, and admin buildings were really close to the goals we were looking at. Sometimes they just needed higher levels of heat recovery. The library needed higher R values. The rec centers, their window to wall ratio needed to decrease a little bit or increase R values for windows and walls. The fire hall already had a low window to wall ratio, but again, it needed some increase in R values. But it was a really great piece of software. Like we could look at incremental capital cost, we could look at life cycle cost on the right and narrow it down to a gap, and then on the left it would tell us what inputs would allow us to achieve those goals. So study 2. Second study involved an actual design team with architects, sub-consultants working on a mixed-use warehouse building. This one was called Ambleside. We had them complete their normal schematic design report like they usually would, but we had them complete 2 additional reports. One for the same building that was 20% more efficient than NACB 2011, and one for a version of that building that was net zero. Note that all versions of the building had to meet the building functional program and all the requirements of the clients. There's no backing off required elements or revised temperature settings or any kind of cheating allowed in this that would sacrifice building function. The consultants looked at various options to improve the base building, and those options had various different levels of cost. For the building they were designing, heat recovery and lighting tended to be the most cost-effective improvements that got us the best bang for our buck, and the envelope, as we discussed, was sort of on the other end of the spectrum. The consultant for that same project also looked at sort of building orientation, to look at solar angles to see, what the optimum building orientation was. When the 3 designs were finally complete, the mid-range option was very similar to the baseline, but making the building net zero required a reduction in the window to wall ratio and also moving to a ground source heat pump system. So study 3 was on a fire hall called Windermere, which is actually constructed now. We again, at this point in time, had the design team complete 3 different schematic designs for 3 different levels of energy efficiency. All 3 options needed to meet the rigorous requirements for a fire station with no compromises or changes on function or operation. And again, when the 3 designs were done, the window to wall ratio stayed the same across the 3 options because it was pretty low already. However, the mechanical system did once again go to a ground source heat pump just to try and get the most efficient system we can. Where did that end us up? Well, it's for C532. Along with these studies, we met with a lot of people. We met with external local consultants. We met with external and internal business partners. And we had a lot of meetings on this. And after a lot of that debate and those studies, we sort of set these targets for C532, 40% more energy efficient than ACB 2011, 40% less GHG emissions than reference building in ACB 2011, and new construction needed to have an annual heating demand or TEDI of less than 80 kilowatt hours per meter squared. So these were viewed as a little conservative or easier to hit by both internal and external parties, but it kept the expected capital cost increases low relative to business as usual. And the annual heating demand was also a bit of a challenge because at that point in time, it was a bit of an education. There was an education piece associated with that. People have come a long ways in understanding TEDI and annual heating demand, but back in 2017, it wasn't as much of a thing. So what does that mean for C627? The new one that came about, we used a lot of that same background information, except now we were referencing an ACB 2017, which replaced 2011 in our jurisdiction. And we got rid of the middle one for greenhouse gas reduction simply because we asked for the building to be emissions neutral. So the building needed to have no greenhouse gas emissions associated with it. And we kept the envelope requirement because that was still very much something we were interested in pursuing and continuing to see. Okay, that covers the history. I'm going to pass it back to Jack. Jack, you're on mute.
Thank you, Sean, for that. Thanks, Mary. So I think you can see that how this all evolved from council declaring a climate emergency to the creation of the sustainability policies, and then Sean and his team really kind of helping to define the requirements that would be needed in order to achieve the policy statement. And so what I want to share now is just some pictures really of some of the buildings that have been built that have been part of or haven't considered the C532 and C627 policy. So what you see in this picture here is our Blatchford District Energy System, which is part of the Blatchford neighborhood, which is our first sustainable community. So this project was one of the city's first big project endeavors driven by a decision by council to have Blatchford as a sustainable community. And the geothermal field that is used to power the district energy system consists of 570 boreholes that are 145 meters or more in depth at a 6-meter spacing. So it's quite a large field. And that's used to power the thermal exchange in the district energy system, which uses glycol within the heat exchange loop. So the building's quite small. Some of it, a large portion of it is underground where all the equipment is. But it's a great little facility that runs the entire, or is part of, will be part of multiple district energy plants in the neighborhood. So next slide, Sean. Oh, thanks. So the other thing I wanted to talk about is the city of Edmonton has invested in a large solar program. The city receives an average of 2,300 hours of bright sunshine a year. So it's a great location for solar photovoltaic installations. And our program continues to grow. And any new construction projects incorporate additional structural supports to accommodate future solar PV installations. Next slide, please. So what you see here is actually the largest rooftop array in Canada. And this rooftop array is constructed on our Edmonton Expo Center and was part of a large rehabilitation project. So There are 5,745 panels on the roof, spanning more than 193,000 square feet and generating about 2.8 gigawatt hours annually. And this is phase one of a multi-phase solar project. The cost of the photovoltaic portion of this project was $5 million, and the PV panels went into operation in November of 2022. The system will result in savings of at least $290,000 a year. The energy offset will be equivalent to the average energy consumption of at least 375 homes. The project has a lifespan of 25 years and is expected to yield payback in 10 to 17 years. That's one of our crowning achievements with our PV program so far. Next slide. This is, Sean shared this with you in some of their development of requirements and analysis of the policy and developing the requirements with industry. This is the actual built Windermere Fire Station. So it's our new net zero fire station. And I wanted to point out the unique shape of this fire station. It's not what you typically expect to see when you pass a fire station. You may typically drive by a station and expect to see a tall hose drying tower or a tall tower or something like that. However, the shape of this fire station is very intentional so that the solar panels on the roof are positioned at the optimal angle to maximally power this net zero station. You'll also notice the doors at the far end of the building. You may expect these to be the same as any overhead garage door on residential or commercial buildings. However, these are bifold doors, which allow for quicker cycle times to open and close. And this helps us achieve a higher degree of sustainability, providing less heat loss and heat gain, depending on the season. Next slide, please, Sean. And this is an image that shows a clear picture of the solar panels on the building structure. And in the smaller photo in the middle there, you can see the bifold doors in the background photo. And next slide. And really, what we want to talk about is how the city of Edmonton builds with purpose and looking ahead. So some of the things that we will be doing in the future, we're investing more into our solar program of work. We have more projects that will be built under the C532 and C627 policies. In fact, I did a little bit of research. Under the C532 policy, we have 9 buildings that are actually LEED Gold certified, and we have 25 buildings that are LEED Silver certified. Our Blatchford Fire Station, which is a new project, will be the first project that is planned to be delivered under our new policy C627, as well as our Riverbend Library and our Rolling Miles Recreation Center. We're planning an expansion of the Blatchford District Energy System. We'll be going forward with a phase 4 project there soon. We have another phase of construction on the Expo Center solar project that we'll be implementing. We're also developing more emissions neutral facilities, and we're looking at heat pump and fuel switching projects in the future as well. Next slide, Sean. So that concludes our presentation. I want to say thank you for your time and attention today, and we're ready for any questions that anybody might have.
Great. Thank you, Jack, Sean, and Mary. Very interesting. So we're now going to move to the panel discussion and the Q&A. And from here, I'm going to hand it over to my colleague, Mike Benson from the University of New Brunswick. Over to you, Mike.
Thank you, Ali, and thank you to all of those presenters. Those were all fantastic. I kind of went into this not knowing what we were going to see and hear, and really impressive work from across Canada and the United States. We did have a few questions that came in from the audience, and I would encourage you, if you're tuning in, you have a question, please do add it to the Q&A. So I'll move to our audience questions first, and then I have a few follow-up questions for the presenters. And first one is for Anna Roback, and this question really speaks to you know, as society and as people, we do a really poor job of accounting for the future. But can you speak to, when we're looking at implementing these resilient solutions, sometimes there's a cost that we incur in the short term. You know, it's a future benefit that we might not realize for a number of years, and it actually might create some adverse conditions. And I think the same could be said probably for some of these sustainable design solutions. But Anna, can you just speak to that tension between accounting for the future and the impact that it happens today, and maybe some words of advice for those that are trying to incorporate those types of decisions?
Yeah, thanks for that question. And actually, I'd be interested in the other panelists' responses to this as well, because they all touched on some cost benefit and some interesting new ways of working. It's true that if you have something right now that isn't prepared for the future, and you have to do something to it to prepare for the future, that will incur costs. And so in general, what we try to promote more of is, if your asset's coming to a point where it needs an upgrade or a replacement, or some sort of change, take that opportunity to embed new, to think a little bit more about the future. We had an interesting panel discussion on accessibility last week here in New Brunswick. And apparently when you're making a new build, designing for accessibility versus traditional design for a building, the cost difference is actually negligible. So sometimes it's not just about thinking about, how do I add this thing on that I haven't had before? Sometimes it's, how do I rethink this thing completely differently, where the costs can remain neutral, but actually I get more benefits out of it than I was expecting. And in the accessibility example, it could be that you actually design your building to have a little bit more open space, or maybe you design it to have a slightly, like maybe 1 foot less of footprint, and then that covers your cost to have a slightly wider door. So there's all kinds of interesting ways that people can be thinking. And it's a matter of not just thinking about, okay, now I need to think about that trend and how I'll incorporate it, and what's the design and the cost implication of that. It's, let's take this opportunity and rethink it all.
Great. Thank you, Anna. Maybe pass it to the Edmonton team as well. Obviously, these new buildings, sustainable buildings, there's a cost increase. Can you talk a little bit about some of the trade-offs that you've had to make internally? Maybe Jack, I'll pick on you.
I'll start just by saying that, yes, we did see an increase in the cost to build the net zero facility. Like, we only have one net zero facility, by the way, which is Windermere, the first one, but we hope we can do more in the future. But I think what we did find, and if I'm not mistaken, is that the premium to actually build that facility was about 14%. So what it means, honestly, is that there are other decisions that may relate to design aesthetic or to program that may have to be adjusted somehow, just in order to get everything kind of constructed. So there will be trade-offs, but I think for the most part, we were very satisfied with the project. It is one of our more expensive fire stations, but on the other side of this, we demonstrated from a leadership perspective, as Anna was talking about being a champion, that this can be done. And yes, there is a premium for it, but maybe it's not as much as we think. And from an operational perspective, I think we'll see a lot of benefits from that side of it, from greenhouse gas emissions and that sort of thing. Anything else, Sean, that maybe I've forgotten?
Yeah, the life cycle cost. We've all talked about it. All of us presenters here, we've talked about the life cycle cost. It's life cycle cost positive. It's like, I can't remember what the number is, but it's like 30 years or something, which for us at the city here, we keep our buildings forever. Okay. Like forever. So it's, that was a big bonus for us. And that was a big, reason for us to push through and make this one go.
That's great. Yeah. And I think, part of it as well is the political will. And I think in Edmonton, you discussed the climate emergency and those policies that have been put in place. I think that really goes a long way. And actually, I think with the utilidors, obviously a significant increase in that original construction cost. And Amin and Terry, you spoke about some of the benefits that you can expect. I'm interested, Terry, from your perspective and with your conversations with the folks at the city, the engineering and public works groups, like what is some of the reception to that type of technology, and what are their concerns with respect to cost or some of the other issues that a utilidor might present?
Okay, well, the work that the working group has done with all of the, and this is graduate student level work. So the life cycle cost benefit was a public policy graduate program, did that. And we've done, I mean, when you show a positive benefit over the term of an asset, it's like, okay, enough studies, let's get serious about this because it's possible to do. So the city engaged a value engineering firm to, and we're not done yet. We spent about 2 weeks, October, November, going through it. There are 10 million issues. Has anyone ever been through value engineering to sort of look at a new process? It spans the whole thing, but where we are now is we spent money on it, which shows some level of seriousness of it, because I think people realize there's money, there are avoidable costs. But the devil is in the detail, and you know, we're maybe halfway through, we haven't seen the interim report. You know, it has to go through this process. I mean, this would be a huge lift because it's kind of a version of what Anna was talking about. It's an infrastructural transition. It's doing things a different way in a dense urban environment. I mean, just doing this is going to be, how do you do it? Where do you do it? I mean, there are a lot of decisions to make, but I will say that through the value engineering process, people were, you know, there's resistance, but there's like, it's part, the value engineering was actually part educational in a way. So, so did that answer the question? Sort
No,
of.
that was great. That's interesting to hear about the value engineering exercise, because I think that does, yeah, kind of gives everybody an opportunity to kind of see the facts and the potential benefits, which is great. A question for Amin. We had a question from our audience asking about risks of these utility tunnels, and I'm interested, Amin, in your research. You know, what are some of the more significant risks that that you've researched, and maybe other examples of where utilidors have failed and have not delivered the value, and how can we overcome those challenges or risks?
Okay, great question. So actually, in our review and also previous studies, as I mentioned, one of the risks is about gas leakage. So if we have gas pipe and in the neighborhood we have high voltage wire, then there could be a potential risk of fire. However, the gas leakage is happening anyway. So under the roads, if we have buried gas pipes, there could be leakage, and most of the time is not detected in a timely manner. There are some vans actually equipped with sensors that will be driving on the roads, and they have sensors that can sniff the leakage. And most of the time, that's not easy to achieve in a timely manner. So once we have things in a tunnel in a very organized way, there's a potential of adding all types of IoT, all types of sensors to give the early warning for any type of leakage, not only for the gas. So this is one potential solution. And the other one is, if you really want to separate things, you can put the gas pipes in a different compartment. That will add to the cost a little bit. And in fact, when we did our case study in Montreal, the gas company called Energir was not very positive, actually. So they didn't really like to participate because there is also a cost implication of their participation. But at the end, as I said, it's like this type of risk have been already considered. There was also an independent consultant that was hired in the past in Montreal to specifically study about this gas leakage problem. And it was found that the risk will be even less when or compared with the case of buried utilities.
That's great. That's great. Thanks, Amin. It's interesting. Question for Edmonton. It's great to see sustainable design practices with these new facilities. I'm interested. A question on the construction side. Has the city explored new construction methodologies like modular or off-site construction compared to your traditional stick build on site, and the potential greenhouse gas emission reductions there, just in the construction of those facilities, or has it been focused exclusively on the design of those buildings?
I can answer that one. I think that right now it's been pretty much focused on the design side of things. We have delivered, that I'm aware of, we have delivered one project that was supportive housing project that was actually, we used modular construction. So the units were built in a factory and delivered to the site and assembled. But when we did that project, we weren't looking at what the potential embodied carbon savings might be or sustainability savings might be with respect to that project. In fact, that was kind of mandated from one of our funding partners, so that we would use a modular construction methodology. So we haven't really done it that much, but I do think that we will be trending that way. One of the things we're doing and considering in terms of procurement is actually including embodied carbon calculations and that sort of thing, so that when we are awarding projects, we've got that information as well as a evaluation criteria for quality-based selection. So we're not quite there yet, but I think moving in that direction.
Okay, fantastic. And a question, maybe a comment. I'd just be interested to hear your perspective. And it was when you were speaking about the barriers and the fear of the unknown and the fear of, or maybe the upfront costs. And it's been really interesting to see over the last 5 years, I would say, kind of the rise in consumer technology and how much more readily available this technology is, whether it's even smartphones, but also, AI and ChatGPT. I mean, can you speak maybe a little bit? Do you notice that when the consumer technology space, new VR, Apple's Vision Pro is all coming out, and have you started to see a shift with some of the clients that you work with and organizations that you're working with, that they're accepting new technology more?
Definitely. And I have to say, when we first hear about these technologies, we think, oh, really want to try these out, really want a willing client to test them out with. And typically there's resistance. People don't want to be the first. But now there's definitely more uptake of all kinds of technologies, smart technologies, as you say, AR, VR. I know a lot of clients starting to use machine learning themselves for all kinds of predictions. So there's massive uptake that, that is now, it's a movement unto itself. And the challenge, I think, now is coordinating that across industry to say, hey, we're doing these things. These are some really good ways forward, and sharing that information amongst each other and starting to share data that they can learn from, that we can all learn from.
That's great. We had a question in the audience here, kind of looking at long-term, I guess, monitoring of success for some of these sustainable projects. I think this is relevant for the buildings in Edmonton, but also the utilidors. And maybe Edmonton, I'll ask you first, what types of monitoring are you doing, or what are the results that you've seen long-term from these new facilities? Obviously, Windermere is a new building, but are there plans to monitor kind of how that building performs compared to maybe how we expected it based on the design stage?
Do you want me to take this one, Jack? Or
Yeah, I'll let you take that one, Sean.
Or Mary, you want to go for it too?
Or Mary.
I was just going to talk about our building energy benchmarking program. So all our city buildings, we track the utilities each year and publish it. And that is a way we can monitor how the energy performance of all our buildings are, including the Windermere Fire Station. Sean?
And then so to slightly get more granular than that, Windermere Fire Station has a lot of metering inside of it. It has a lot of gas meters, a lot of electric meters, all measuring different things. Like we have some things as backups, and so we've already been using these meters. We've been using these meters to troubleshoot the operation of the building as it's been going through its first year. We were actually there on site 2 weeks ago, looking at some of these meters and trying to figure out why some things were not turning on, turning off, or so yeah, no, there's an advanced energy metering credit as part of LEED. So if it's one of an optional LEED credit that you could, well, not optional, it's a LEED credit out there that you can go for. And we did that, and then we kind of built on that. And so yeah, we have a pile of meters and we also have a trending system. We have a trending system that takes our building automations data and sends it up to a cloud. And so we can track every temperature, every pressure, everything in that building. For a long period of time, which again is super helpful for troubleshooting issues on that building.
Yeah, like I'm just wondering, and this is related to one of the questions we got about, like the solar panel efficiency, and it has the theoretical efficiency, and then of course the snowfalls, and it's having a hard time collecting. Like, it's only probably been one winter, but I'm sure you've had your solar panel program is quite extensive. I mean, have you seen the energy gain that you were expecting? Is it been more than you were expected, less than expected, or kind of you're pretty close to those estimates?
So I can only comment on Windermere, and Windermere is hitting expectations for sure. Like the consultants gave us what they expected those panels to produce in schematic design and in design development, and they're up to this point, knock on wood, it's hitting it. So for us here in Edmonton, it's cold, it's snowy in the winter, but the reality is we don't have any sun hours in the winter. Most of our sun hours are in the summer. That's when our panels are really doing their work. And so the snow, local institution here called NATE, Northern Alberta Institute of Technology, did a great study on the effect of snow on solar panels at our latitude, and there wasn't much of an effect in terms of clearing them off or not clearing them, just because that's not where the majority of our sun hours are in a year. Like in the summer, you should come here in the summer. It's great. We have like 14 hours of sun. So that's really where we see the gains from a solar perspective.
Excellent. Well, I think I'm actually planning to come down to Edmonton in May, so it's a little early for summer, but it'll be my first trip to Edmonton. Looking forward to it. Ali, I think, are we 2 minutes to the close of the session? Do I have my times right?
Yes, that's correct. I think we have a minute now. So if you have any last quick questions, you can go for it. If not, we can kind of wrap it up.
I have lots of questions, but I think it's probably a good time to wrap it up. So I'll pass it back to you, Ali, to close us off.
Perfect. No, that's all. Thank you, everyone, for attending, and a special thanks to all our presenters for a great session. We will share the video recording of this session soon. So thank you again, and we hope to see you all again very soon. Have a great rest of your day. Bye-bye.
Yes,
Thanks for
thank
having
you
us.
for having us.
Bye.
Bye.